Let's see if we'll play. Okay, recording's going. All right, so let's get the show on the road. Welcome to the most wonderful ENGR210 class you'll have this entire day. We talk about loops, also known as going in circles. So for loops or not for loops, that is the question, because in Python there are two ways of repeating instructions. If you think back to when we did the Fibonacci sequence code back last week, we were just doing the same thing as many times as we wanted to get numbers out, right? If we could just have the computer run the code a billion times, that'd be awesome, because then we can control how much code is repeated. And for certain tasks, especially when you get into computational modeling, you're iterating, and that's what going in loops called, over hundreds or thousands of data points, and the number of data points can change. So it'd be nice if you could kind of have a way of coding that can adjust to that without us having to do anything. And that's what a loop is. So we're going to start our exploration of loops, our looking at loops, if you would pardon the alliteration, with for loops. So as I said, there are two kinds of loops, while loops and for loops, at least in Python. We're starting with for loops. So for loops are very particular in that you use them to run a particular set of code a particular number of times. That's kind of the gig with them. They are made to run a particular number of times, and they keep track of how many times that they've run. So if I'm, excuse me, say I want to add up all the numbers from 1 to 10. One way of doing it is this. So x is going to be the variable that is all the numbers that I've added up. And I'm going to want to add all numbers from 1 to 10 in it. So what I'm going to use is a for loop. Start that off with a for. The two big parts of a for loop are the variable that changes. I'm going to call that our loop variable. That is always an integer. Well, most of the time it's an integer. And the iterator, or what you want to loop through. So let's see what these things actually are. See if we can play with them a little bit. So, oh, did I not? No, boo. Un moment bitte. I did not bring up PowerShell. There we go. There's PowerShell. All right, PowerShell. Make it bigger and share it. Excuse me. There we go. Cool. Someone mind? Well, it's already down half. Never mind. They're going to switch the lights in this room, so you can do left and right, so that when wash out is bad, but it is what it is. All right. So I just went into my Python interpreter. So if you're following along, this is the same as writing in your console. All right. So I'm going to type in what I had for range. So 0, 10, 1, right? I think that's just what I had down. For reference, just gonna write it on the board. If you look back at the PowerPoint, well, that's a really crappy marker. That was a really oh, I almost had it on the bounce. Okay. So in the PowerPoint, the command was for I in range 0, 10, 1. Then there's a colon and whatever the stuff inside of it was. So looking at this second part of that range 0, 10, 1. If I hit that, rather if I, it says that, but I want to see what's in it. Thought I could print that. Dang it. Hang on. Nope. Oh, all right. Quiet you. When I changed computers, started working a little differently than I'm used to. There it goes. All right. So, can you turn both lights off, please? Thanks. Just so we can all see it. All right. So, I have to parse this a little bit more. Thank you. Figured that everyone has the light of their own computer for right now. So, if I look at what I just did, let's see if we can parse this out by like doing some forensics. So for I in range 0, 10, 1, what this means, what this range command means, is that this is going to these are all the numbers that I can iterate, that I'm going to iterate over in this for loop. It's going to start at 0. It's going to end when I get to 10, and it's going to advance by 1. So you might think of it as start, stop, step. You start at 0, you end at 10, you step by 1. We can kind of we can intuit that I takes on the value of whatever the next value in this range command is every time that I go through the loop, because I have this print I command, right? Print means display it, right? So whatever the value of I is, it prints it every time it goes through the loop. It starts at 0 and it increments by 1 each time through. However, it only goes to 9. What the heck? I thought it went to 10. And the thing we have to keep in mind with that is that when we stop at 10, it's because the program is running like this. I come to the for loop. I say, okay, for I in range 0, 10, 1. Okay, so my I starts off at 0. I go into the loop, I is 0. Okay, I do whatever's in the loop. I come back to the top. Okay, increase by 1. I is now 2. Am I at the end yet? No. Okay, do the loop. I is 1. Come back up. I is now 2, 3, 4, 5, 6, 7, 8. Eventually I get to, okay, I is 9. Okay, I'm not at the end yet. Print 9. Come back to the top. I is called add 1. I is now 10. I'm at the end. Skip everything that's in the loop. I'm done. Does that logic make sense? We cool? Okay, cool. So whatever is in here, you'll see that value minus up to that value minus 1, or minus whatever your step is in your for loop. All right. So for that example of adding all the numbers up between excuse me, between 0 and 10, how do I get to 10? Because obviously this doesn't. Yeah. Thank you. So if I go like that, great. I see all numbers from 0 to 10, but I want to add those all up. And what I should get is, what? Do we have any people who like playing that game? What should I get here? So fun way of doing it. If you take the first and last numbers, so that's 10, that's another 10, it's a third 10, it's a fourth 10, it's a fifth 10, plus 5. So I should get 55 out when I add when I add all these up. So the code that I had was what? X equals 0 to start things off, and then for I in range 11, 1, x equals x plus I. Now let's look at what that does before we hit go. So I start off here, x equals 0. First time through this loop, I equals what? 0, right. And I'm not at 11 yet, so I can do everything that's in the loop. So I come in, everything that's in the loop, same as with an if statement, is everything that's indented. So I come in, x equals x plus I, x is 0, I is 0, so x equals 0, right? Great. Where do I go from here?
right, as a circle back up, I advance I to the next value in my iterator, which is 1, because this now contains all numbers from 0 to 10. Okay, I equals 1 now. I'm not at 11, so I keep on going through my loop. What does x equal now? What did it equal when last time that we were here? 0. I think, at least I think I heard someone say 0. So x was 0, right? I is now 1, and everything on the right saved on the left. So just look at the right hand side. 0 plus 1 is 1. X is now 1. We all following there? Cool. All right, so x is now 1. Come back up here. I is now, it was 1. 2, right, so now it's 2. I'm not at 11 yet, so I can pop down here. X is now, say again. I hear 3. Consensus on 3? Cool, because because if I look at the right-hand side, x was just made 1. I is 2. 2 plus 1 is 3. X is now 3. Okay? Cool. So if I go again, I is now 3. Remember, x is also 3 now. Come down here. 3 plus 3 is now 6. And so on and so forth until I get to the end of the loop. If I run that, the print statement there. Note that the print is outside of the loop because it's not indented. Oh, and of course it doesn't like it. Boo. Hang on. And we'll see that x is 55. Just the way that it should be. Any questions with that? Cool. If you do this in your scripting window, it might be a little bit easier to navigate the tabs and stuff. I'm just doing it here because I'm doing it quick and dirty. All right, cool. There are no if there are no questions, we shall continue. Pop back over into here. Could you hit one of the lights again, please? Just one of them. Thank you. All right. So everyone can wake up now. All right. So as said, that's a for loop. This is the form of the iterator that we used. Honestly, the start value and the step value are optional. We don't have to put them in. If you don't, it'll start at 0 and it'll step by 1. If you want to do something else, put something else in. But it is exactly the same thing to take for I in range 0, 10, 1 and write for I in range 10. Those do this exact same, those will iterate over the exact same set of values. So if you plug those into that script that we just wrote and try it, it'll just work. Exactly the same that it did before. One kind of neat thing about Python, though, and something that we'll be using in the next few weeks, month or so, depending on which one you're talking about, is that when we talk about iterators, anything can be an iterator in Python. Strings, names, words, files, anything. It's cool. It's super cool. I am like so psyched about it because it's friggin' awesome. So for example, I'm gonna pull up my window again. So if I just gonna pop over into Vim.
call this an example of iterators. So if for I in range, for I in spell Python, and I print I every time through the loop. Oops, sorry. If I do something like that, do that, instead of printing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's printed out each character of my iterator, each letter, the space, and then all the letters of the second word. It's a really cool thing about loops in Python and what you can use for iterators. I think it's super awesome, but I'm going to try not to get nerded out about it yet. So let's play the game of loops without all this other crazy stuff. All right, get this out of the way. All right. So how can we? So we've talked about how we can do it. How can we blow it all up? So I mentioned that loop variable. It likes to be an integer, or in that case, a string. It does not like to be floats. So an easy way to get an error is to define your range with floats, which, remember, is anything with a decimal point. So if I do for I in range this, this, and this, it is not going to be happy. It is not going to be happy with you. You will get an error from that. So don't do it. Always use integers when you're using the range command. All right. That's probably the easiest way to screw up a for loop. However, there are some other commands we can use in conjunction with the for loop. But before we get there, how are we feeling about loops? Does logic make sense? How to use it make sense? Any questions, concerns? Sweet. All right. So other things we can do with loops. So sometimes we might want to get out of a loop in a hurry. So we're going to use the break command. It is not the command that you use to get coffee. Same thing, just different. So turn this thing over. There we go. All right. So back over into here. Let's redo this, guys. So it's for I in range, let's say 15. So we should have all the values from 0 to 14 come out of in this loop at some point, right? All values from 0 to 14. And I'm going to say, just print whatever I is. Actually, I'm going to be fancy. This is iteration I. All right. I'm gonna get fancy now. I'm gonna ask a question. I'm going to say if I equals 4. If I equals 4, I'm gonna say break. Okay. So the program should run 0, 1, 2, 3, 4 times before it hits that, before that if statement is true. Correct? All right. So let's give this a shot. So what happened here? What happened?
What would you call, what do we, yeah, go on. Right, because we'd expect this to run 15 times. We'd expect it to say this is iteration 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. But it stopped. And it stopped on the iteration that that if statement was true and it hit the break command. So what break does is it departs from a loop. It says, forget about all the rest of the work you have to do in this loop. You're skipping into everything else and you're done. Let's play with that a little bit more. Oops, not that. Okay, so after that if statement, I'm going to write print. This is the end of the loop, or sorry, the end of the iteration. All right, I'm just going to add a little print statement saying this is the end of the iteration. It's still indented there on line 7. It's just further down. Sorry, I'm going to try to make this a little bit better for people on this side of the room. So because it's indented, it's part of that loop, right? So that should run every time. Let's give that a shot. Oops. All right. So what's going on here? So this is iteration 0, and then whoops, there we go. Come back to me. HDMI, go everywhere. HDMI, go everywhere. Thank you very much. There we go. Now I'll catch up in a minute, or so I hope. So we start on iteration 0, went to the end of the iteration, 1, printed at the end of the iteration, 2, 3, 4. 4 didn't. So not only does the break statement get you out of the loop, it gets you out of the loop immediately. It didn't even finish that iteration. So that's kind of interesting. There we go. Well, let's take it a step further. Back over into here. Okay, I'm going to add a second loop in here. Just like you can nest if statements, you can nest loops. So I'm going to come up here and say for x in range 3, print this is sub iteration x. So for x in range 3, this is sub iteration x. Note that I'm not using the same loop variable in these two for loops. If you remember how we said that for loops work, they just take that loop variable and they add 1 to it each time, right? So if I change that loop variable inside of my loop, it's going to screw up the whole thing. So if you nest loops or just in general, you cannot redefine what that loop variable is. The for loop has to be in control of it. You just have to let it be. So let's see what that does. All right. So the one up there, I'd say this is iteration 0, sub iteration 0, 1, 2, end of iteration. Okay, you have that repeated for 1, 2, 3. Then 4 got absolutely nothing. So it skipped that other loop too. But what if we put that break statement inside of that second for loop? So I've moved that if in the break inside of that second for. Let's see what that does. That's interesting. It ran to the end this time. But let's scroll up a little bit. Here's iteration 5, 4. Look at iteration 4. What happened to it? Say again. Right. So if I look back at my code, I say, hey, it's called 4x in range 3 print. This is sub iteration blah. So if this was iteration, if this was the iteration where I equals 4, it would come down to print. This is iteration 4. Come down here, x would be 0, right? Come down here, print. This is sub iteration 0. This would be true, correct? It would run this. It would break. But what stopped? We just saw no more of these sub iterations in printing. We did see this print statement. We saw this is iteration 4, this is sub iteration 0, and this is the end of the iteration, right? So the break statement didn't break both loops. It only broke one. It only broke the loop that it was it broke the loop that it was closest to, if you will, the one that it was immediately inside of. So when we use a break statement, it's only going to break one loop at a time. I'd have to put a second break statement in if I wanted to end this guy early. So that can be kind of handy, depending on what logic you're trying to enforce in your code. And this is, and if you haven't noticed it yet, this is where we're going to start moving from, okay, typing in a math problem to you have to sort through the logic of your code. Because these are really, all these are, there's no defined way to use a for loop outside of how many times do you want to do it for and throw a variable in there, right? What these are tools. And you get in your job as programmers, as engineers, is to see how to try to apply that tool. So a lot of our homework is going to move to more of that of a mentality. So just something to keep in the back of your head. There's no script for this. It's purely up to you. Game on, which is why coding is awesome. Okay, so any questions about that? Great. All right. You have a few other tools that you can use. One example is the continue command. So I'm just going to move that if statement to above the print this time. And we don't have to scroll up through as many. I'm going to change the range to 5. Okay. Changing the range to 5, putting in continue instead of break, and moving that continue to above the print statement. All right. Python, for example, go. Okay. Oh, actually, hang on. I want to do this instead. This make it more evident. Instead of I equals 4, x equals 4, or x equals 1. All right. So what did that do? Remember, it was if x equals 1, it would run that continue statement. So what did the continue statement do? What's different with all these? if I had a break instead of a continue, I shouldn't see this is sub iteration 2, right? It should have ended that loop and moved on with life, right? But it didn't. It just skipped an iteration, and that's what the continue command does. When the program hits continue, what it does is it skips the rest of that iteration and moves on to the next one. It doesn't stop the loop. It just skips ahead to the next iteration. So if I look at this a little more closely, let's try to reason this out. So let's just step through it. Python goes line by line, so we'll go line by line. Okay, so first time here, I equals what? Don't everyone say it at once? 0? 0, right. So I equals 0. Okay, next line prints this is iteration 0. Okay, come down to the next line, x equals what? Yep. Okay, if x, so go into the for loop, if x equals 1, is that true? No, so I skip that, print this is sub iteration 0. Cool. Where to from line 7? Goes back to what? Well, the next thing down is indented one thing out. So that means that I've hit the end of my for loop. I'm going to go back to the start of that for loop. And I only go up to this one here, because that's the one that I'm presently in. And I haven't finished it yet. So come back up to line 4, say, okay, add 1 to x, because that's my default step value. X is now 1. It's less than 3, so I can keep on going. So if x equals 1, this is true now, right? So I hit continue, skip back up to the top again, add 1 to x, it's now 2. Go down here, false. This is sub iteration 2, and that's what we saw print out, right? Comes back up here, x equals 3. I'm done with my loop, so I skip over everything that's indented. I inherit this print statement. Print. This is the end of the iteration, and I keep on going until this loop is done. Cool beans. Sweet. All right. So that's for loops for you. No pun intended. All right. Honestly, that's good there. That's good there. All right. Excellent. Let's. So that's for loops. Our other kind of loop is a while. So let's talk about that. For loops are cool because they count for you. You can set them to run for a certain amount of time, but they can't do it. But they can't do everything. Like if if I was using your atmospheric pressure calculator, and I wanted to compute pressure at every 1,000 feet from here to the top of the stratosphere. I'd have to do some math in order to make a for loop do that, right? I'd have to say, okay, how many 1,000 feet are here between here and there? Okay, so I'm starting at 2,000 because that's about here, going up to 65. So it's what, 63 divided by 2. It's like 31-ish. Just add 1 because I'm starting it here. Yeah, you have to do a little bit more work, and then you can count that all out. Because you'd have to do that 32 times in order to go every so many 1,000 feet from here to the top of the stratosphere. This is the nice part about a while loop. It'll loop while a condition is true. So in this case, x starts off as 1. I check this condition, it's true. So I come down into my loop, I add 1, now it's 2, come back here, yeah, it's still true. Okay, add 1, x is 3, still true, come back down here, x is 4. Okay, now it's false and it leaves loop. That's how a while loop works. It loops while something is true. Now, I can use the same conditions and nuance that I can do with if statements. Like I can say, while x is less than 3 and y is less than 4, or while x is less than 3 or y is less than 4, or whatever. I can ask the same questions that I can in an if statement to make a while loop run. All right? Can do all that the same way. So let's give that a shot. All right. So I'm over here. I'm just going to comment out all my if statement stuff for a minute. All right. So x equals 3. While x less than equal to 3, x equals x plus 1, 1, and we're going to print x. All right, make it pretty straightforward. So x equals 3, while x is less than or equal to 3, x equals x plus 1, print x. So what this should do is every time through the loop, I should add 1 to x and print whatever x is. Cool beans? So, just wait for one more second. How people type. All right. So, I get, there you go. Oh, so I already did that. Whoops, hang on. X equals 1, not 3. There we go. And this is what we'd expect. X equals x plus 1, you get 2, and 3, and 4, and if you had 4, x is greater than 3, so it's absolute. Great. That was easy. But there's a very key part about while loops. Very, very key. Say I don't get, I'm going to get rid of that line where I update x. Actually, I'm going to say just x equals 2. All right. Or no, actually, let's be even more crazy. I'm going to say x equals x minus 1. Okay. So I'm going to run that. You don't run that one, by the way. Don't run that. So I'm going to run that. Is it ever going to stop? No, it's not. And this is an example of something not to do, and which you can stop by pressing Control-C. It's a very, very important command. Control-C is your best friend. You ever want something to stop, press Control-C a couple of times. So, according to the condition that I put in, the while loop will always run while x is less than or equal to 3. Based on the math and the logic inside of the loop, meaning that x equals x minus 1 thing. So x is always going to be decreasing by 1. And I'll just print that out. X will never be greater than 3. So this loop will never stop. It is an infinite loop. You'll be in that forever. And, well, I've just screwed up my code. So that is pitfall like numero uno with while loops. If you find yourself that your code's just not doing anything for a really long time, and it's normally very, very fast, and you have a while loop in there, this is probably what's going on. You just have to click into your console window and hit control C. All right. So moral of the story: be very careful of when your loops end, when your loops are set up to end, because if you aren't, you could get hit with this problem of infinity, if you will. So these two loops are kind of the tools in your toolbox in Enjoy. Now we're going to move forward with using them. Rather, you will on the homework and in lab. Any questions on loops? You can nest while loops the same. You can nest for loops. You can put while loops inside of for loops, inside of if statements, inside of more for loops and while loops and stuff. You can stack them however you want. Put them in whatever order. You can slice them. You can dice them. You can fricassee them. They're awesome. All right. So do a quick thing so that you have it for your homework. So Python's a very modular language. You can pull things into it. You can take things out of it in order to get more operability. So for example, I can't do cosine, the cosine function in Python. Like if I go over to the console window and type cosine of 3, it'll go, "What the crap are you doing? I don't know what cosine is." So what people did is they made packages to support different handy functions. So that's why I have the NumPy package, or the numeric Python package, scientific computing, math, or a plotting library. So you can plot things, you can interpolate, you can do math, you can do all kinds of fun stuff. We're going to look at NumPy first, because NumPy is where a lot of the handy stuff is. So let's play the game. Make sure it's shared. Good. All right. So I'm going to delete everything. Okay. So example of NumPy. So in order to get NumPy, you have to import it. You always want to import at the start of your code. You want to do it as soon as essentially you write the introductory lines of comments. Because if you don't do it there, it'll be buried somewhere and you'll forget that you did it. So I'm going to write import NumPy. And I'm going to write import NumPy as, actually I'm just going to write import NumPy for right now. A couple of NumPy functions that we can use is one's cosine. So if I want to find the cosine of pi, say. So I'm going to say pi equals 3.141592653589793238, whatever. So there's this, yeah. And then we're going to say some variable called output. We'll say that is the cosine of pi. So we get cosine by naming the library that has the cosine function. And the cosine function is cos. So just NumPy library dot the name of the function. And then to use the function, we just put pi inside of that. And we'll just print whatever output is. Okay, so cosine is a function just like print. You have that same open paren, close paren, whatever you want the function to work on. You put it inside the parentheses. You get it from the NumPy library. So NumPy dot whatever the function is how you get it and use it. So give that a shot. Cosine of pi is 1. So there we go, or -1, right? So there we are, great. Now, if you were using a bunch of different things not from NumPy, writing NumPy every time would be annoying. So you can get around that by saying, I'm going to import NumPy as something else. I'm going to give it another name. Usual one's NP. Now, instead of writing NumPy, just use that. And it'll do exactly the same thing. Cool beans. All right. So there are a number of different commands that we'll be using from NumPy besides trig. You can look them up online if you just search NumPy or NumPy cosine or NumPy sine or NumPy whatever. It'll pop up with the reference manual and tell you what names they are. So yeah, let's just show you that quick. Let's look up a random number generator because it's fun. Let's make sure that this is sharing that. Great. So I'm going to look up NumPy random number generator. And this is the NumPy manual, so it should be the right place. Here we are. I'm going to grab just the first one here, rand. So this is saying if I want to use this function, it's numpy.random.rand. So this is how I can this is how I can get more the names of more functions and use them. I just have to look. I just have to look them up here, and how to use it is kind of just described here, along with a couple of examples. If you look down at the bottom, so this is a handy little reference. Being the online NumPy manual. All right, cool. All right. So it has all kinds of fun stuff. There's trilinear interpolators over in SciPy. We'll talk about that later. But that's all I got for today. If there are no questions, thanks for stopping by.